drought, hurricanes, and heat waves. Man-made climate change and global warming in the United States. The year 2012 in perspective. 2012 was a wonderful year for the reporting of man-made climate change and global warming. There were a number of weather events in the United States that were used to promote the concept, including the drought, that's now lasted for 3 years, Hurricane Sandy, and the heat wave. They were dreams come true for reporters of man-made climate change. In this video, we'll examine the exceptional and historic nature of the recent drought in the United States, and see how well the IPCC's climate models simulated precipitation in the U.S. since 1900. And we'll look at how well the models performed globally during the satellite era. We'll also examine the 2012 hurricane season in an attempt to put it into perspective. And we'll examine the sea surface temperatures along Sandy's storm track to see the impact of global warming on that hurricane. We'll also examine how well the climate model simulated sea surface temperatures along Sandy's track since the last monster storm to hit the Northeast. There was also a heat wave in the United States in 2012. Should United States heat waves occur more often in a warming world? And how well do the IPCC's climate models simulate U.S. land surface air temperatures? Last, we'll briefly discuss global warming in general. Let's start with the drought. Pretty severe drought conditions existed in broad portions of the United States in 2012. The website Climate Progress had a few recent blog posts about the drought. These included, "Still hurting in the heartland, the historic drought continues," and "Exceptional drought conditions expand in the U.S., likely persisting through February." Now, is the current U.S. drought exceptional or historic, as the people at Climate Progress would like you to believe? And what do the climate models prepared for the upcoming IPCC report have to say? There are a number of data sets we can use to examine whether the claims of exceptional and historic are correct. These include the Palmer Drought Severity Index. Also, based on the Palmer Drought Severity Index, NOAA publishes the percentage area of the United States that has moderate to extremely dry conditions. And of course, there's precipitation data. We can then compare that to climate model outputs. If you've never heard of the Palmer Index, here's a quick overview from NOAA's Palmer Drought Severity Index webpage. The Palmer Index is most effective in determining long-term drought, a matter of several months. It uses 0 as normal, and drought is shown in terms of minus numbers. For example, -2 is moderate drought, -3 is severe drought, and -4 is extreme drought. NOAA breaks its Palmer Drought Severity Index data into regional subsets. Let's start with the southern region. The data, starting in 1895, is also available in a number of formats from the NOAA website. This graph shows the 12-month averages ending in November. The December 2012 data wasn't yet available from NOAA when I prepared this video, but this data will give us an idea of where we stood for the year. As we can see, the southern region has a low Palmer Index value for 2012, but there have been lower values in the past, especially in the 1950s. Since the drought has lasted for 3 years, let's look at a 3-year running average of the data. Current drought conditions in the South have been exceeded 3 times since the late 1800s. So it's tough to claim that the current conditions are exceptional or historic. The Palmer Drought Severity Index data for the contiguous United States are shown next. The current conditions are still not exceptional. They've been exceeded at least 5 times before, and some of those droughts have lasted for multiple years. In fact, looking at the 3-year averages, the current drought pales by comparison to the conditions in the 1930s and the 1950s. So calling the current drought conditions in the U.S. historic or exceptional is plainly nonsense. Let's move on to the data set NOAA has prepared that presents the percentage of the United States with moderate to extremely dry conditions. We can see, based on the average for the last 12 months, about 46% of the United States is experiencing dry conditions. But much more of the country was dry in the 1930s and 1950s. Considering the drought has been going on for 3 years, let's look at this data using a running 36-month average. Current conditions are in no way exceptional or historic. That's 2 data sets that show the headlines on climate progress were nothing but baloney. The next data set is NOAA's precipitation data. It's available to the public through the Royal Netherlands Meteorological Institute website called the KNMI Climate Explorer. The Climate Explorer allows users to select the coordinates of the data. Referring to the recent NOAA drought map of the United States, we'll use the coordinates of 34 north to 46 north and 104 west to 94 west for the data. This map shows the area we're looking at. That precipitation data is available on a monthly basis, so we'll use 12-month averages to give us an idea of where we stood for the period ending in November 2012. As we can see, while the precipitation last year was low, it has been lower since 1900s numerous times. When looking at 36-month averages, because the droughts lasted for 3 years, we can see that the precipitation for the hard-hit drought area regularly has less precipitation. Let's expand the precipitation data to capture more of the United States. We'll use the coordinates of 32 north to 48 north and 108 west to 88 west, or this area. Again, there has been less precipitation dozens of times before. Using 3-year averages of the data shows the recent bout of low precipitation is not exceptional or historic, regardless of what the alarmists at Climate Progress would like their readers to believe. And how well did the climate model simulate precipitation for this portion of the United States? I've smoothed the data in this graph with 120-month filters to remove more of the visual weather noise. The trend lines, however, are based on the raw data and the raw output of the climate models. And for the climate models, we're looking at the average of all of the simulations from all of the models, what's referred to as the multi-model ensemble mean. The climate models presented in this graph are from the CMIP-5 archive, which was prepared for the IPCC's upcoming 5th assessment report. The average of all the climate models say if greenhouse gases were responsible for the increase in precipitation, the precipitation should have increased at a specific rate, and it's about 3/1000ths of a millimeter per day per decade. But the precipitation in this area increased at a rate that's more than 3.5 times faster. In other words, the IPCC's climate models show no skill at being able to simulate regional precipitation for a major portion of the United States. Ponder this for a moment. If precipitation in the United States has been increasing since 1900, how then could man-made global warming be responsible for a 3-year drought? How well do the models do on a global basis? To discuss global precipitation, we need to switch to another of NOAA's dataset. This one's called CAMS-OPI, CAMS-OPI. It uses rain gauge data and satellite-based data for complete coverage of the globe, from pole to pole. Since much of the data is from satellites, the data starts in 1979. Based on the linear trend, global precipitation has decreased over the past 34 years. However, the climate models say it should have increased if global precipitation was driven by man-made greenhouse gases. In other words, the climate models can't even get the sign right. They say global precipitation should have increased, but it fell by a comparable amount. To sum up precipitation and drought, there was nothing exceptional or historic about the recent drought in the United States. Also, climate models show no skill at being able to simulate precipitation on regional and global basis. Please understand, I'm not trying to make light of the drought or any of the weather-related metrics discussed in this video. The drought has harmed many farmers. Speaking of droughts, that's how we're going to transition to the discussion of Hurricane Sandy. Roger Pilkey Jr. reported in a December 3, 2012 blog post that the record U.S. intense hurricane drought continues. He writes with respect to this graph, "The graph above provides an update to data on the remarkable ongoing U.S. intense hurricane drought. When the Atlantic hurricane season starts next June 1st, it will have been 2,777 days since the last time an intense, that is, a Category 3, 4, or 5 hurricane made landfall along the U.S. coast." And the last one was Wilma in 2005. Such a prolonged period without an intense hurricane landfall has not been observed since 1900. In other words, we've been extremely lucky in recent years. Keep in mind, Hurricane Sandy, while it was a remarkable storm in many respects, may not have even been a Category 1 hurricane when it made landfall. Hurricane researchers are still studying that. It's tough to imagine how much worse it would have been if it had been a Category 3, 4, or 5 hurricane. And it could have been a stronger storm. 2012 was also below average for hurricanes in terms of NOAA's extreme weather indices. Here's the graph of the NOAA extremes in landfalling hurricanes since 1900. 2012 hardly registered it was so far below normal. 2012 was also not an exceptional year in terms of accumulated cyclone energy for the globe and for the Northern Hemisphere. Yet somehow Sandy became one of the poster children for global warming and climate change alarmists. Even in the face of all of that data, there are those who believe that somehow man-made global warming was responsible for Hurricane Sandy. In fact, if you were to Google global warming and Hurricane Sandy, with both of them in quotes, there are more than 3 million returns. There's nothing to indicate global warming was responsible for Sandy. Why? Because the warming isn't global. Some parts have warmed and others have not. We know that hurricanes are fueled by seasonally warmed North Atlantic waters. And we know Sandy's storm track. So it takes only a few minutes to go to the KNMI Climate Explorer and plot the sea surface temperature anomaly data of Sandy's storm track. I've started the graph in 1938, which was the year of the Great New England Hurricane, also known as the Yankee Clipper, the Long Island Express, or simply the Great Hurricane. And the data set is NOAA's Extended Sea Surface Temperature Reconstruction version 3B. Here, let's have Excel add a linear trend line. As we can see, based on the linear trend, the sea surface temperatures for Sandy's path have not warmed in 70 plus years. They've actually cooled slightly. When Sandy continued north out of the tropics and became a baroclinic hurricane, there was an escalation in the nonsensical claims. These included things like Hurricane Sandy was part of a new normal, Sandy had the fingerprint of global warming, and, of course, dirty energy makes dirty weather. Oy vey. If we look at the sea surface temperatures for that extratropical portion of Sandy's storm track, we can clearly see they've cooled over the past 70 plus years. Another thing, let me remove the linear trend and add a line that represents the October 2012 value. Now we can see that there was nothing unusually warm about the October 2012 sea surface temperature anomalies. It was warm, no doubt about that, but it has been surpassed dozens of times over the past 70 plus years. You know what? The new normal looks the same as the old normal. And what do climate models say? If sea surface temperatures for Sandy's track were warmed by greenhouse gases, they should have warmed about half a degree Celsius since 1938, but they've cooled slightly. And for the extratropical portion of Sandy's storm track, again the climate models show the sea surface temperatures should have warmed about half a degree Celsius, but they cooled almost 0.3 of a degree. In summary, the only thing unusual about the 2012 hurricane season was that it was below normal in many ways. Also, the sea surface temperature anomalies for Sandy's track haven't warmed in more than 70 years. It's tough to claim global warming was responsible for Sandy when the sea surface temperatures for the extratropical portion of Sandy's track have actually cooled over those 70 plus years. Maybe those persons making the baseless claims were looking at climate model outputs, which once again show no basis in reality. The next topic is temperature in the United States. Looking at the temperature anomaly maps for January through November of 2012, it was pretty warm for the entire year, but March stands out as the month with the freakishly strong heat wave. Think back. Persons were out and about in shirt sleeves then. It was a great break from winter chills. Well, unless you were someone concerned about global warming, then it wasn't so wonderful. Let's look at graphs of annual and March land surface air temperatures for the United States using the same coordinates shown in those maps. We'll be using the GHCN-CAMS dataset from NOAA, since it's the only land surface air temperature dataset available in absolute form. All the other datasets are presented as anomalies. The GHCN-CAMS dataset starts in 1948. Here we have a graph of March land surface air temperatures for the United States starting in 1948. And for the sake of discussion, we'll also provide the climate model simulations of March land surface air temperatures for the same region. Again, the climate models are from the CMIP-5 archive that was prepared for the IPCC's upcoming fifth assessment report. The upsurge in 2012 shows how freakishly warm it was last March. There's no doubt about that. Curiously, though, the climate models show that if the United States surface air temperatures were warmed by greenhouse gases, the warming during the month of March since 1948 should have been much less. In other words, the climate model simulations show too little warming, by a factor of more than 3. The climate models didn't perform so well with this either, did they? You might be thinking the climate modelers could not have anticipated the weather conditions that created the 2012 outlier temperatures last March. So let's end the data in 2011. The March warming trend of the climate models is still off by a factor of more than 2.5 times. That's horrendous. Let's look at annual surface air temperatures where the data ends in November. 2012 was an unusually warm year. But the comparison to the models shows us something else. On an annual basis, the models have now overestimated the rate of warming, meant by about 35%. That's still pretty bad. Looking at the month of March, the IPCC's models underestimated the rate of warming, but on an annual basis, they overestimate the warming. That suggests the seasonal factors are off in the models. And if we remove the 2012 outlier again, by ending the data in 2011, the models are overestimating the annual warming by more than 50%. You know, the IPCC's climate modelers have been at this for more than 2 decades. And that's the best they can do? Do climate models have skills at anything? Speaking of climate modelers, James Hansen of the Goddard Institute of Space Studies made his way to the national news this year with his recent paper and his loaded climate dice, answering questions about heat waves. That was a head-scratching moment for me. Why? Ask yourself, why do we need a computer modeler to tell us that we'd have more heat waves in a warming world? Regardless of whether the warming is caused by man-made greenhouse gases or through natural ocean processes, there will logically be more heat waves while global temperatures are warming. On the other hand, there would be more cold spells when global temperatures are cooling. Even a grammar school student can figure that one out. Go ahead, ask your children. During a long-term period, Johnny, when global temperatures are warming, are we more likely to have heat waves or cold spells? Come on, if a grammar school student can reason that one out, why is it newsworthy? James Hansen's appearance on the news was remarkable to me in a comical kind of way. They could have used a 9-year-old to answer that question. Let's look back a couple of years. The 2012 heat wave in the United States is reminiscent of the 2010 Russian heat wave. This year, Kevin Trenberth and John Fasulo of the National Center for Atmospheric Research presented a paper that described the natural factors that caused the 2010 Russian heat wave and other weather events that year. Ultimately, they blamed the 2009-2010 El Niño and the trailing La Niña for the Russian heat wave, but then added, however, there is also a significant global warming component, and they refer to Gillette et al. 2008. The human influence is systematic and persistent and can be thought of as the underlying warming of the order of 0.6 of a degree Celsius since the 1950s, while there are large regional and temporal fluctuation superposed on this warming by natural variability. The problem is, anyone who understands sea surface temperature data would have questioned that statement immediately. So much for peer review. Here, let me show you. Trenberth and Fasulo used the unusually warm sea surface temperatures for 4 small regions to determine the source of the heat wave and the other weather events of 2010. But they failed to advise readers about the lack of warming of the sea surface temperatures for the overall ocean basins that encompass those 4 regions. Using the same dataset as Trenberth and Fasulo, the sea surface temperature anomalies for the Indian and Pacific Oceans from pole to pole have not warmed in 19 years. 19 years! And that's a period when climate models say the sea surface temperatures for those 2 ocean basins should have warmed more than 0.3 of a degree Celsius. But they haven't warmed for almost 2 decades. So, we can probably anticipate a scientific paper this year or next that explains the natural causes of the 2012 heat wave in the United States. Of course, there would be a reference to man-made global warming. Therefore, we can probably also anticipate a blog post in response to that paper, similar to the one that I wrote this year, which points out the errors in the claims of man-made greenhouse gas-driven global warming of the oceans. If you're not aware, the satellite-era sea surface temperature data and the ocean heat content data, which is available starting in 1955, show that Mother Nature is responsible for the warming of the global oceans, not man-made greenhouse gases. I'll give you a quick overview. To keep this portion of the video short, I'm not going to explain how and why this happens. I will, however, at the end of it, let you know where you can find those explanations. Arthur C. Clarke once wrote, "How inappropriate to call this planet Earth when clearly it is ocean." This is a graph of the sea surface temperature anomalies for the global oceans. It indicates they have warmed about 26/100ths of a degree Celsius or 47/100ths of a degree Fahrenheit over the past 31 years. The data is from a satellite-based dataset, which is why it starts in November 1981. In addition to the satellites, it also uses measurements from buoys and ship inlets. It provides complete coverage of the global oceans. The data in this graph is based on the best sea surface temperature dataset available, and that's NOAA's Optimum Interpolation Sea Surface Temperature Data, version 2. It's also known as Reynolds OI.V2. We're going to break the data down into 2 subsets, the East Pacific and the rest of the world. The East Pacific represents about 33% of the surface area of the global oceans, and obviously that means the rest of the world data covers the other 67%. Here's the graph for the sea surface temperature anomalies of the East Pacific region. Based on the linear trend, it hasn't warmed in 31 years. Does this agree with your understanding of man-made global warming? This is a graph of the sea surface temperatures anomalies for the rest of the world. I've highlighted 4 periods in red. Those are strong El Niño events. The first one, the 1982-83 El Niño, was counteracted by the explosive volcanic eruption of El Chicón in Mexico, and that's why the data looked so funky at that time. The dip and rebound, starting in 1991, was caused by the eruption of Mount Pinatubo. With those volcanoes in mind, as you can see, the only time the sea surface temperatures warmed for the rest of the world was in response to the El Niño events highlighted in red. We can confirm this by deleting the warming effects of those El Niños and replacing that data with flat lines. The sea surface temperatures for the rest of the world would not have warmed without those El Niños. Does this agree with your understanding of man-made global warming? That global warming is dependent on El Niño events? Let's move on to ocean heat content data that's available from the National Oceanographic Data Center. They're also known as the NODC. The ocean heat content data is based primarily on temperature measurements to depths of about 700 meters or 2,300 feet. The data begins in 1955 because there are too few temperature measurements at depth before that time. You may have heard of Argo floats. They've been used for the last decade or so. And before that, temperatures at depth were measured primarily through electronic thermometers attached to very long, thin wires that were dropped over the sides of ships. Those sensors were called XBTs. Salinity measurements are also included in this dataset, so the units are joules. We only need to look at two portions of the oceans to show that data contradicts the hypothesis of man-made global warming. El Niño and La Niña events take place in the tropical Pacific, so let's look at the ocean heat content data there first. There are three periods highlighted in red. They capture 3-year La Niña events. That's three 3-year La Niña events. Between the three 3-year La Niñas and the short period after the last one, the ocean heat content for the tropical Pacific cools. The cooling is so great that it's easy to see the tropical Pacific would cool over the long term since 1955 if those 3-year La Niñas did not exist. Based on the linear trends, the data cooled for 49 of the 58-year term of the data. And there's also a natural explanation for the 9 years of warming, the 3-year La Niña events. Does this agree with your understanding of man-made global warming? That the warming of the tropics is dependent on 3-year La Niña events? If we remove the effects of the 1995-96 La Niña and the 1997-98 El Niño, the cooling from 1976 to 1995 is even more pronounced. Does this agree with your understanding of man-made global warming? Let's move on to another portion of the Pacific. We'll look at the ocean heat content for the area of the North Pacific that's north of the tropics. Based on the linear trend, it cooled quite rapidly from 1955 until 1988. It's tough to say greenhouse gases caused warming in the North Pacific while it was cooling. Then there was a 2-year upward shift in the ocean heat content. After it, North Pacific ocean heat content warmed. But without that 2-year shift, the ocean heat content for the North Pacific cools over the term of the dataset. Does this agree with your understanding of man-made global warming? That for the North Pacific, the warming is dependent on a 2-year period where the warming is likely a result of a shift in sea level pressure and wind patterns? Remember, even though our planet is called Earth, the oceans and seas cover 70% of it. If the hypothesis of man-made global warming does not work for the oceans, it doesn't work for the planet. Obviously, that hypothesis needs to be reevaluated. The natural processes that cause the warming of global sea surface temperature and ocean heat content are further presented with data, not climate models, in the two-part video series, The Natural Warming of the Global Oceans. They're also discussed in detail, again presented with data, in my book, Who Turned on the Heat? It's only $8, so please buy a copy. In this section of the video, I repeatedly asked the question, does this agree with your understanding of man-made global warming? If you're a true blue believer in man-made global warming, you are likely thinking of excuses. The bottom line is, the sea surface temperature and ocean heat content data do not agree with the hypothesis of man-made global warming. So the hypothesis is flawed. Instead of manufacturing excuses, you may want the IPCC to fix the hypothesis. The climate modelers have wrongly assumed the warming of the global oceans was caused by greenhouse gases. That means that IPCC's computer modelers are also wrong in their attribution studies of all of the other metrics associated with man-made global warming, including Arctic sea ice loss, glaciers melting, sea level rise, etc., and so on. Also, based on the terrible performances of the climate models that we've seen in this video, you may want the IPCC to fix them too. They performed horribly simulating regional temperatures and precipitations, and they performed unbelievably poorly with precipitation on a global basis. To that end, for the closing of this video, let's return to the Trenberth and Fasullo paper. If you weren't aware of this, they could not use climate models to determine the causes of the 2010 Russian heat wave and the other weather events that year. What, you say? It's true. Trenberth and Fasullo noted, it remains a challenge for climate models to correctly simulate mean rainfall distributions, and as a result, it is even more of a challenge to reproduce anomalies and associated teleconnections such as those observed in 2010. And the reference they had for that was Yang and Del Sol, 2012. They continued, however, unless the diabatic heating, mainly from latent heating in precipitation linked to sea surface temperature anomalies, is properly simulated in both its spatial and temporal character, it will likely not be possible to simulate, predict, or fully attribute blocking events and climate anomalies such as observed. They were not kind to the climate models. How badly do climate models simulate the spatial and temporal characters of sea surface temperatures? Here's a graph that shows how the IPCC's climate models simulate the warming of the Pacific Ocean from the Southern Ocean surrounding Antarctica on the left to the Bering Strait on the right. The units in the graph are the linear trends in degrees Celsius per decade, and the time period is the last 30 years. The climate models show that there should have been a significant warming in the tropics. On the other hand, the observed sea surface temperatures warmed in a totally different pattern. There was no warming at the equator and little warming in the tropics, and the vast actual majority of the warming took place in the mid-latitudes. El Niño and La Niña events distribute warm water from the tropics toward the poles. That's what El Niños and La Niñas do. When Mother Nature creates a multi-decadal period during which El Niño events are stronger than La Niña events, like we've experienced since 1976, more warm water is transported towards the mid-latitudes than normal. But the climate models obviously don't work that way. The first problem, climate models can't simulate El Nino and La Nina. The second problem, as Trenberth and Fasulo noted, climate models don't simulate teleconnections well. So they can't simulate the effects of El Nino and La Nina throughout the globe. And those problems clash with any hope climate modelers may have at short-term weather predictions. And that's one of the objectives of the IPCC's upcoming Fifth Assessment Report. In other words, the IPCC will be making claims about decadal and multi-decadal regional climate that are beyond the capabilities of the climate models. But that's nothing new. The IPCC has been doing that since their first assessment report. Well, that's it for this video. Y'all have a nice day.